Hi, and welcome back. We're going to have our final lecture today, which is covering sections 11.1 and 11.2. We're going to really discuss quadratic equations and how we solve those quadratic equations using various methods. So the first thing that I'm going to go over is something called square root property. Now, square root property seems very intuitive. That is, if I have any value squared equal to b, then technically the square root of that value, being a, is equal to the positive and negative roots of b. Now you might be saying, whoa, you lost me. Check this out. If I'm looking at the square of r, so r squared is equal to 5, then technically what I'm saying is that if I were to take the square root on both sides, so square root on both sides, this becomes r, but on this side, I have to do the plus or minus value of the square root. Because if I were to take the square root of 5 and multiply it against itself, I should get my original value of r. And if I were to take the negative square root and multiply it against itself, I should get the same value. So it's very important to make sure you have that plus minus value in here for the square root property. So that is all you would have solving for r. Let's try another one. Let's say I have 48x squared minus 4x squared minus 48 is equal to 0. That's what I get for reading ahead, right? Okay, so I have 4x squared minus 48 is equal to 0. Now, to solve this out, I'm actually going to move this 48 over. I'm going to divide by 4. And so when I do, that's going to be 12. To solve even further, I'm going to take the square root property and apply it. So this becomes x equals the plus or minus square root of 12. This can technically simplify, so I will simplify it. So that's x is equal to plus or minus root of 2 square root of 3. Remember, 12 can break down into 4 and 3. Perfect square root of 4 is 2. And there you go. You get two possible answers. This is an appropriate format to use, that plus minus symbol. You could also write it as x is equal to the positive 2 square root of 3 or the negative 2 square root of 3. Either or is correct. Good. Let's try another. And I'm going to get all of my board space back while I'm at it. Let's say I have 3x squared plus 54 is equal to 0. Well, first things first, let's move that 54 over. I have 3x squared is equal to a negative 54. Very good. Can I divide by 3? So that gives me x squared is equal to a negative 18. Now we're going to take the square root, so that's x is equal to the plus or minus square root of negative 18. Remember, the square root of a negative is an imaginary value. So this is technically x is equal to plus or minus I square root of 18. So don't forget to pull that imaginary value out. Now the square root of 18 can simplify, so we will do that. That's technically 9 times 2. Perfect square of 9 is going to be 3, so x will equal the plus or minus 3i square root of 2. Very good. What if I get something like this? I have 2x minus 3 as a quantity squared is equal to 18. Well, in this situation, I'm going to say let's use the square root property, just as is. Here's why. I have something squared is equal to some other value. That's exactly what I had here. I had something squared is equal to some other value. I'm going to do the same exact thing. Taking the square root on this side, I get just the 2x minus 3. Taking the square root on this side, I have plus or minus square root of 18. Excuse me on that. At this point, I am going to move this 3 over, and I want you to be very careful and see how I do that. The 3 goes in front of the plus minus sign, so it goes in front of this operator of plus and minus. I'm going to simplify my 18 at the same time. This is going to be 3 square root of 2. Divide by 2, so x is equal to 3 plus or minus 3 square root of 2, all of this divided by 2. Now, very important point to make, particularly if this were imaginary. It is not for this problem, but if it were, you would have to split this up so that you have your complex number format. You don't have to worry about it in this situation because everything is real. So that is awesome. And I just lost my place. Here we go. Number 5. So I have x minus 3 as a quantity squared is equal to 25. We're going to do the same thing, square root property. So take the square root on both sides. This side goes to x minus 3 is equal to the plus or minus square root of 25. This is x is equal to 3 plus or minus 5. Now this square root worked out, which means we can simplify this expression. Now there's two expressions here. You have 3 plus 5, which is 8, 3 minus 5, which is negative 2. So x has two solutions, and x had two solutions here as well, hence the plus minus. Let's do one more. And then I want to show you another method. So I have 3k plus 1 squared is equal to 2. So 3k plus 1 squared is equal to 2. Let's use square root property because I have this whole term squared. So that's 3k plus 1 on this side, plus minus square root of 2 on this side. Move my 1 over. I have 3k is equal to 1 plus or minus square root of 2. Divide by 3. K will equal 1 plus or minus square root of 2, all divided by 3. And that is perfectly acceptable. Now, shifting gears just a little bit, but building off of the square root property is a technique that works every single time for solving quadratic equations, which is known as completing the square. Okay, so sorry about that small little break in there. I had to talk to security because they were about to kick me out of the building. It's almost the end of the day here. So that being said, let's talk about completing the square. Completing the square is something that sounds really scary, but it is actually very, very easy. So I want to introduce you to a format called the standard format for a quadratic, or quadratic standard form. Now, in this standard form, you have a, b, and c terms, all in descending order, and you're equal to 0. Now, a, b, and c are constant or coefficient values, and your x is the only variable here. Sometimes this is factorable, and you used zero product property in the past whenever it was factorable to be able to solve this problem. However, sometimes it's not factorable. Sometimes you have something like the square root property, which we just covered, and you could easily solve. Other times, it's not so easy. So let's take a look at what we can do, which is called completing the square. If I have a problem, for example, x squared minus, that might help if I actually write this correctly, x squared minus 4x is equal to 5. Now, I know what you're saying. You're probably like, wait a minute, did he just cut out 4 problems on the last page? No. I didn't cut out those 4 problems. The reason I'm actually not using those 4 is because they are incomplete. So I don't want to use those 4 problems just to prove a point. I'd rather show you the process, which is what we're going to do here. So I have x squared minus 4x is equal to 5. This, while technically factorable, is not something that I'm going to do right now. This is going to be where I complete the square. I'm going to add in a mystery term to both sides of my equation. Now you might be saying, ooh, I love mysteries. What do I do with a mystery term in math. Check this out. For this completing the square to really work, what I'm going to do is make sure that my coefficient value on this leading term, this x squared, is 1. I am then going to say that my mystery term is 1/2 b squared. 1/2 b squared. What do I mean? I mean b from up here. So I have 1/2 of b, my b in this case is 4, and I'm going to square it. So 1/2 of 4 is 2, squared is 4, so I'm adding 4 to both sides of this problem. Just showing 1/2 of 4 is technically 4 over 1, same idea. Now, in this case, that's x squared minus 4x plus 4 is equal to 9. Now this side, we want to see if this side can factor. As a spoiler, whenever you complete the square, this side will factor. And it does something very special. When it factors to identical terms, to identical binomials, exactly the same. So that means you can then use the square root property because you have something squared is equal to a value. So let's use the square root property. I have x minus 2 is equal to plus or minus 3. Add my 2. X is equal to 2 plus or minus 3. Or x is equal to a -1 or a positive 5 once you simplify it. So what did I actually do? What was the completing the square part? Right here is completing the square, CTS. What I'm seeing is that I added a mystery term into my problem. This mystery term was how I completed the square so that I could have something that is factorable, potentially from an unfactorable problem. And then I factored it down. I got to where I can use square root property. So square root property. And then I used just simplification from here. So you factored in here just to give you some notes. So you complete the square by adding that mystery term, you factored, and then you use square root property and simplified. Let's try another one. I have x squared minus 8x minus 5 is equal to 0. Now, looking at this problem again, it is not factorable, but what I can do is I can go through the process of completing the square. So I'm going to add this 5 term over. My lead coefficient is currently 1, by the way. So I have x squared minus 8x plus some mystery term, because I'm going to add that mystery term in, is equal to 5 plus that same mystery term. Now let's figure out our mystery term. That's going to be 1/2 of our b value, that's 8, squared. Well, half of 8 is 4, squared is 16. This side works out to 21. This side you have x squared minus 8x plus 16. Now, let's factor. This is going to be x and x. Factor pairs of 16 that give you 8 are 4 and 4. Signs are the same and they're both negative. That's x minus 4 squared is equal to 21. You can now do the square root property, so that's x minus 4 is equal to the plus or minus square root of 21. That doesn't really work out, so just move that 4 over. X is equal to 4 plus or minus the square root of 21. And now from a non-factorable problem, you can actually get a solution. And it totally makes sense why it wasn't factorable, because you have a nasty looking decimal value right here, that radical. Now, I want to point out a little shortcut for you. The shortcut's really cool. What was your half of 8 squared? It was 16, right? But what was it before you squared it? Half of 8 was 4. Well, check that out. Your factored form comes out to 4. Interesting. Let's go over here, back to a problem that we just did. In this factored form, you had 1/2 of 4, which was 2, squared, gave you 4. But before you squared it, it was 2. Your factored form contained a 2. So, as a shortcut to save you a little bit of factoring steps here, you could actually say that before you square this mystery term, whatever that happens to work out to, that will be in your factored form. And you should have x, whatever this sign is, and whatever this term is before it is factored. So you had x minus the 4. That's where you got it from. And you know that completing the square will always give you the same exact pair here, binomial pair. So you have x minus 4 quantity squared. Completing the square is beautiful because it allows you to go from doing this mystery term, adding that in, to using square root property. And you will always use square root property in this process. Then from here you can simplify. Let's try another one. I just want to prove a point here. Not really, I actually want to go through examples. That way you can see how it's done. So this next problem is 4x squared minus 32x, plus 32x, excuse me, minus 3 is equal to 0. Yep, looks right to me. At this point, I want to complete the square, but I need to get this lead coefficient to be 1. So I'm going to divide everything here by 4 before I move anything around. So I have x squared plus 8x minus 3/4 is equal to 0. I'm going to add that 3/4 over and add my mystery term in. So I'm going to have x squared plus 8x plus mystery term is equal to 3/4 plus mystery term. Okay. My mystery term is 1/2 times 8 squared. Half of 8 is 4. Squared is 16. That is my mystery term. I know this side's going to factor down, so I'm just going to go ahead and jump using my shortcut. It's going to be x plus, because it's using this sign. Half of 8 is 4. My whole quantity here is still squared. Is equal to, and now I can spend a little bit of my brain power on this side because I have a fraction and I have a whole number. So I do need to get this so that it is in a common denominator. I lost my lights again. So that's going to be 16 over 1, which is going to then have to be multiplied by 4 over 4. So that'll be 64 over 4. That is 67 over 4. So I have x plus 4 quantity squared is equal to 67/4, just like so. At this point, I can use my square root property. That gives me x plus 4 is equal to the plus or minus square root of 67 over 2. I took my square root of 4 already. I'm going to move my 4 over. And so this will be x is equal to negative 4 plus or minus the square root of 67 halves. Just like that. Okay, let's do one more, and then I'm going to shift gears a little bit. So I have 3x squared plus 4x plus 4 equal to 0. Again, something that's not factorable, but I can use complete the square. So at this point, I'm going to divide by this 3 first, just to clear out everything. So that's going to be x squared plus 4/3 x plus 4/3 is equal to 0. Ooh, I've got fractions. That's okay. Bear with me. Move this 4/3 over. Add in some space for your mystery term. Now looking at my problem, I need to get that b, half of b term right here. But you're dealing with a fraction. What does that mean? For you, not much. What you have to do is just say 1/2 of my b term, which is 4/3, squared. What's half of 4/3? 2/3. Squared, I'm going to have 4/9. So half of 4/3 is 2/3. Squared is 4/9. So we're adding 4/9 to both sides. Now, remember our shortcut. You don't really have to do a whole lot of mental processing on this side. So I know I have x plus, this is going to work out to 2/3 before you square it. So that's x plus 2/3 quantity squared. And that's why I used the shortcut. So I use half of that b term before I square it right here. My whole quantity is squared because I know I'm coming down to square root property. Now this side I can work on my mental processing. I can work through this math. So this first term is negative 4/3. I need a common denominator of 9. So that's a negative 12/9 plus 4/9. This is a negative 8/9 once I simplify this. This side, x plus 2/3 quantity squared still. Do your square root property. You get x plus 2/3 is equal to the plus minus. This is an I value, so be very, very careful. I'm going to take it in steps. That's a square root of negative 8 over 3. Took my square root already. I'm going to work it right here just really quick. So that's a plus minus 2I square root 2 for this negative 8 in the radical. That's still over 3. Now this 2/3 has to be moved over. So I have x is equal to a negative 2/3 from this term moving. Plus or minus, I have 2 square root 2 over 3I. Now, notice I moved my I from this position to outside. And that's simply because I'm looking at my A plus BI format. I'm looking at my proper complex number format. And that's all I'm doing there. This is done. Leave it alone. It looks nasty, it looks messy, but it's actually very beautiful and it is the solution. So leave it alone. Okay. Now I'm going to do another one. And I really want you to watch this one very, very carefully because this is actually going to give you something that is very, very awesome, known as the quadratic formula. And some of you are like, oh no, the quadratic formula. It's okay. Trust me. Quadratic formula comes from completing the square. So I have my standard quadratic form. I need to get this lead coefficient to 1, so I'm going to divide everything here by a. So I have x squared plus b divided by ax plus c divided by a is equal to 0. Now, at this point, I need to go ahead and move that c divided by a term over, and I need to add my mystery term in. So I have x squared plus b over ax plus mystery term is equal to negative c over a plus mystery term. My mystery term, remember, is that 1/2 of my b value. That's this whole thing now, this fraction, which is 1/2 b over a squared, which once I solve this out as much as I could, it's actually going to be b squared over 4a squared. Okay, I know. You're looking at it like, what? Don't worry. This side, we already know we can take out some mental processing. We know we're going to get a binomial squared because we're completing the square in this process. And this comes down to square root property. I have x plus, because I'm using that sign. This term is my b over 2a before I squared it. So it's b over 2a. Now I can work a little bit on this side. So I have a common denominator of 4a squared. So I need a 4a over here. So that's minus 4ac over 4a squared plus my b squared over 4a squared. I can combine my like fractions, my like rational expressions here. So that's b squared minus 4ac, just to make sure I don't drop a sign in the process. This is over 4a squared. This side hasn't changed at all, so just bring it down. At this point, you can apply your square root property. So this becomes x plus b over 2a is equal to, this side goes to the square root plus or minus square root of b squared minus 4ac. You're dividing that by, you can take a perfect square root here, that's 2a. I'm then going to move my term over, so this is x is equal to b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. Because I already have common denominators, I am going to combine these. So that is negative b plus or minus square root b squared minus 4ac divided by 2a. And that is equal to x. Now, you're looking at this and thinking, what are you talking about? You are a crazy person. I can promise you I am not that crazy. I'm just a math instructor. So, looking at this, what am I looking at? What is this telling me? It's actually beautiful. It's a song. It's math. It's math song. Check this out. This is what we call the quadratic formula, and it works every single time as a formula for solving quadratic problems. The reason it works is because it is actually completing the square, which works every single time as well. But this is a shortcut method. Now, I did mention it's a song, so check this out. I want you to practice this. I want you to sing really, really loud because I can't hear you on this side, but it's great dinner conversation as well. So check it out. Think of Jack in the Box, right? Okay. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Boom. Marker drop. That's what I'm talking about. These are song lyrics to the greatest song ever known, mathematically. So, what we're going to do is we are going to practice the quadratic formula. Now, the first problem is x squared minus 8x plus 15 is equal to 0. I need to identify a, b, and c. So I am in descending order. I am equal to 0. I have to be in that standard quadratic form, which I currently am. A is 1. B is negative 8. C is positive 15. So there are my three terms, A, B, and C. I know x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It sounds crazy, but when you actually sing it, I notice people on a test, they're like, you're humming it, and I know you're thinking back to how awesome I am by singing this song. And I'm talking about you, not me, singing. Now, that being said, getting a little cocky there, let's plug in our values. So I have b, which is a negative 8, so I have a negative 8, plus or minus the square root of b squared, which is a negative 8 squared, minus 4a, which is 1, c, which is 15, all divided by 2a, which is 1. So I've got all of my values plugged in. I can then go through and say x is a negative 8, which is 8, plus or minus negative 8 squared is 64, minus 4 times 1 is 4, times 15 is 60, so that's minus 60 there. All divided by 2 times 1 is 2. X will equal 8 plus or minus 64 minus 60 is going to be 4, square root of 4 there, over 2. x is equal to 8 plus or minus 2 divided by 2, which means 8 plus 2 is 10, divided by 2 is 5. 8 minus 2 is 6, divided by 2 is 3. X is either 5 or 3. Boom. You mathed it there. All you had to do was use that quadratic formula. You didn't have to go through and complete the square. You didn't have to go through and use square root property. You didn't have to go through and even factor the thing. You just used the formula. So quadratic formula, which is this baby right here, is one that you definitely want to memorize. And it's very easy. Sing it. That's all you got to do. Let's try another. I have x squared plus 3x minus 29 is equal to 0. I am currently in standard quadratic form, so this is beautiful. A is 1, B is 3, C is equal to a negative 29. Let's plug in our values. So I have x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 29 divided by 2 times 1. Now, of course, you can use a calculator here because sometimes the values get a little bit hairy, and that's okay. But you got negative 3 plus or minus the square root. 3 squared is 9. 4 times 1 is 4. And then 4 times 29. Ooh, think about it. 4 times 29, you should come up to a positive, because it's double negatives here, positive 116 divided by 2. This is going to be x is equal to a negative 3 plus or minus the square root of 125 divided by 2. X is equal to a negative 3 plus or minus, this will be 5 square root of 5, once you break it down, over 2. And that is it. Leave it alone. Oh my, the blue marker. The blue marker does not erase. That's okay. Let's see if I can get another eraser to work. Nope, the blue marker smears. That's okay. We're going to do the last two problems anyway, and we're going to use that blue marker. So my next problem, I have 2x squared minus 2x is equal to a negative 1. Am I currently in standard quadratic form? No, I have to be equal to 0 for that form. So let's go ahead and rearrange. So I have 2x squared minus 2x plus 1 is equal to 0. Identify a, b, and c. And then plug into your formula. So you have negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 2 times 1 divided by 2 times 2. X will be equal to positive 2 plus or minus the square root. That'll be 4 minus 8 over 4. X will be equal to 2 plus or minus, this will be the square root of a negative 4 divided by 4. Now, remember this negative is going to be imaginary. So what I'm going to do is, at this point, I'm going to split my problem up. I can do that because I have an operator right here. So I have x is equal to 2/4 plus or minus. I'm going to pull that I out at the same time in the square root, so that's 2/4 I. Simplify your values. X is equal to 1/2 plus or minus 1/2 I. And there you are. So quadratic formula, again, super, super easy to use. Yes, there are a lot of working parts to it, but it's super easy to remember. So you have x is equal to I don't know what I'm just writing. Haha. I need to get my thumb on the right position. Here we go. We got x squared minus 5x plus 20 is equal to 0. Okay, and this is our actual last problem. Cool. So that being said, this problem, technically you could go through and do some different things with it, but it's already in standard quadratic form. So I'm going to say a equal 1, b equal -5, c equal 20. And I'm going to say, let's do this. Let's get the quadratic form out of the way. So x is equal to -5 plus or minus the square root of -5 squared minus 4 times 1 times 20 divided by 2 times 1. So I got a 5 plus or minus the square root. This will be 25 minus 80 divided by 2. So I have x is equal to 5 plus or minus the square root of a -55 divided by 2. 55 doesn't break down for me, but that's okay. So what I'm going to do at this point is pull out that imaginary value and just leave it alone. So I have 5/2 plus or minus, this is square root of 55 over 2i. And there you have it. Okay, so just to recap where we are, because we have talked about a lot of information here in the last few minutes. For our lecture prior to today, we talked about zero product property, which is something that's worth revisiting, because if you have a factorable problem, you could easily factor it and use that zero product property to solve it. We talked about square root property today, so something that is easily used in the completing the square method, but if you see square root property and you can apply it, boom, just do it. Completing the square works every single time. Don't forget to use that mystery term as you add it in. And then, of course, you have quadratic formula. Quadratic formula is really awesome to use. And as it's being used, you can actually sing along with it. So go with it. Here's the credits for you. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Boom. Thank you, guys.